It is a sight that has captivated humanity since the first moment we possessed the capacity for wonder. The night sky, a velvet drape pierced by countless points of diamond light, feels both intimate and infinite. We perceive it as a dense tapestry, a solid canopy of brilliance so close you feel you could almost reach up and run your fingers through the river of the Milky Way. This is the cosmos as we have always known it, a universe of substance, of light, of crowded grandeur. It is a beautiful, profound, and deeply comforting illusion. For the true nature of the cosmos is not one of plenitude, but of absence. The overwhelming, dominant reality of the universe is not the light, but the void that cradles it. To begin to grasp this, we must dismantle our earthly intuition about what it means for space to be empty. We must embark on a journey of scale, a mental exercise that pushes the boundaries of our imagination. Let us start with our own solar backyard. Consider our sun, that brilliant, life-giving sphere that dominates our sky. It is in reality a colossal engine of nuclear fusion, nearly 900,000 miles in diameter. Now, let us shrink it down to something more manageable, something we can hold in the palm of our hand. Let us imagine the sun as a single perfect grain of sand. On this scale, the Earth becomes a microscopic speck of dust, orbiting at a respectful distance. But the true lesson begins when we look for our sun's nearest neighbor. The closest star to our own, Proxima Centauri, would be another similar grain of sand. The instinct is to place it a few inches away, perhaps on the other side of a table. But the reality of cosmic distances mocks our parochial senses. On our sun as a grain of sand scale, Proxima Centauri is not in the same room, nor the same building. It is not even in the same town. That other grain of sand would be over 4 miles away. Picture it. 2 solitary specks, adrift in a silent black vacuum, separated by a gulf of emptiness so vast it defies everyday comprehension. All that space, filled with nothing but the faintest whispers of radiation and the occasional wayward atom. This, it is crucial to understand, is the crowded part of the universe. This is our local stellar neighborhood, a region we consider relatively dense with matter. If this is the metropolis, then the true cosmic countryside is a desolation beyond imagining. Now pull the camera back further. See our Milky Way galaxy in its entirety, a magnificent swirling pinwheel of light containing over 100 billion such stars. It looks like a solid, glowing whirlpool, a dense city of suns. But this, too, is a trick of perspective, a collective lie told by aggregated light. If you were truly piloting a vessel through this galactic city, you would not be navigating a dense forest of light. Your experience would be one of profound loneliness. You would be a solitary sailor on a dark, shoreless ocean, where the distant lighthouses are so far apart that centuries of travel at impossible speeds would separate one sighting from the next. The average distance between stars in our galactic arm is about 5 light-years. That is 30 trillion miles of pure, unadulterated nothing. You could aim your ship in 1,000 different directions, and in almost all of them, you would encounter not a single atom of solid matter for generations, but the final and most complete shattering of the illusion comes when we pull back one last time. To view the universe on its grandest possible scale, we see then that the galaxies themselves, these great island cities of stars, are not scattered randomly like flour in a jar. They are structured, arranged by the invisible hand of gravity into the largest known pattern in existence, the cosmic web. This is a universe-spanning architecture of brilliant filaments and dense glowing knots where thousands of galaxies huddle together in clusters. And it is in viewing this web that we finally see the truth. The galaxies are merely the glittering decorations. The real substance of the structure is the darkness between them. The glowing filaments are separated by immense spherical bubbles of near-total emptiness, the cosmic voids. These are not mere patches of slightly thinner space. They are the dominant feature of the cosmos, occupying over 80% of the volume of the observable universe. They are the great deserts, the silent black oceans between the archipelagos of light. The star-filled sky we adore from our tiny planetary outpost is a local phenomenon, a trick of perspective born from our position within one of the dense filaments of the web. We are like a person standing on a well-lit city street, surrounded by other bright buildings, assuming the entire world is just as bright and crowded. We have not yet ventured into the vast, dark, and empty countryside that makes up most of the world. So, the next time you find yourself beneath a clear night sky, take a moment to appreciate the magnificent deception. The seemingly solid ceiling of stars is in fact the thinnest possible sprinkling of luminous dust across an infinite black canvas. The universe is not primarily a place of light and matter. It is a place of silence and space. It is a void, gentle and absolute, and the lights we see are nothing more than fleeting, isolated embers in an ocean of unimaginable and beautiful darkness.
When we say the universe is mostly empty, our minds instinctively reach for familiar ideas of emptiness. We think of a vacuum chamber in a laboratory from which the air has been meticulously pumped out. We think of the dark, silent space between the Earth and the Moon, which we rightly call the vacuum of space. But these are crowded, bustling places compared to the true, cosmic definition of emptiness. To understand the voids we are about to explore, we must first redefine the word itself, pushing it beyond its earthly meaning into a realm of almost philosophical abstraction. Let us begin with what we think we know. The space between our planet and the sun, for instance, is indeed a vacuum. It is absent of air, absent of sound, absent of the molecular soup that makes life on Earth possible. But is it truly empty? Not at all. This near-Earth space is flooded with energy. It is saturated with the relentless stream of photons from the sun, bathing everything in light. It is crisscrossed by the sun's magnetic field and filled with the solar wind, a constant supersonic flow of charged particles. It is a dynamic, energetic highway. Even in the darker, colder regions between the planets, there is still a faint, diffuse mist of atoms and molecules, a handful of hydrogen and helium particles per cubic centimeter. It is a thin haze, to be sure, but it is not nothing. Now, let's journey further out, beyond the protective bubble of our sun's heliosphere, into the space between the stars, what astronomers call the interstellar medium. This is the space we traversed in our previous thought experiment, where stars are separated by light years of darkness. Here, the density plummets. In some regions, we might find only a single atom in a space the volume of a sugar cube. This is a vacuum so profound it makes any created on Earth seem laughably impure. Yet even here, there is structure. There are wispy clouds of molecular gas, the birthplaces of future stars. There are nebulae, glowing with the light of embedded stellar nurseries. There is the faint, ubiquitous energy of the cosmic microwave background, the afterglow of the Big Bang, permeating every cubic inch. It is vast and dark, but it is a darkness pregnant with potential, the raw material of future cosmic cities. This brings us, at last, to the true meaning of emptiness in the context of the cosmos. We are no longer talking about the vacuum between stars within a single galaxy. We are talking about the space between the galaxies themselves. This is the realm of the intergalactic medium. Here, the numbers become so small they almost lose meaning. The average density of matter in these regions can be 1,000,000 times lower than in the interstellar medium within our galaxy. We are now dealing with a universe where a volume of space the size of a modern skyscraper might contain only a few lonely atoms. This is not merely a vacuum. This is a profound desolation. But the emptiness of the cosmic voids, the subject of our journey, is even more extreme. It is not defined solely by the absence of atoms, but by the absence of potential. In the interstellar medium, the gravity of the galaxy pulls matter together, eventually forming stars. In the great voids, the gravitational pull is not inward, but outward. The structure of the cosmic web means that the voids are actively being emptied. The little matter that was there is being siphoned away, drawn towards the dense filaments and clusters that form the web's architecture. A void is not a static, empty bubble. It is an expanding bubble of negation, a region of the universe that is being systematically and relentlessly evacuated. Furthermore, this cosmic emptiness is defined by the absence of light, not just the light of stars, but the light of entire galaxies. To be in the heart of a great void is to be in a place where the nearest galaxy is so distant, so faint, that if you were located there, your night sky would be almost perfectly, utterly black. No Milky Way, no Andromeda, just a handful of faint, ghostly smudges. The lonely inhabitants of an immense darkness. The energy of the cosmic microwave background would still be there, and a few wayward particles. But to all human senses, it would be the most absolute nothingness one could ever experience. So, when we speak of the emptiness of space in this cosmic sense, we are describing a multi-layered concept. It is a geometrical emptiness defined by the vast distances between structures. It is a material emptiness defined by a density of matter so low it approaches non-existence. And it is a dynamic emptiness, a region that is actively being carved out and maintained by the gravitational dynamics of the universe itself. It is not a passive backdrop. It is an active, dominant feature. The glittering galaxies are the exception. The great dark and ever-growing voids are the rule.
If the star-filled sky is an illusion and the emptiness between stars is profound, then the true architecture of the universe presents us with a paradox that challenges our very perception of reality. To comprehend the great voids, we cannot simply look at the places where there is nothing. We must first understand the intricate, beautiful, and darkly majestic structure that defines where there is something. We must acquaint ourselves with the cosmic web, the fundamental skeleton upon which the entire visible universe is arranged. Imagine for a moment that you could shrink down, small enough to fit the entire observable universe within a vast, dark room. Now imagine you have a supply of glittering dust, each speck representing a single galaxy. If you were to toss this dust into the air, you might expect it to form a roughly uniform cloud, a haze of light diffusing evenly throughout the space. This was, in fact, the default assumption for much of astronomical history, that on the larger scales, the universe was essentially smooth and homogeneous. But when we finally developed the tools to map the universe in 3 dimensions, a very different and far more startling picture emerged. You would not see a uniform cloud. Instead, you would witness a structure of breathtaking complexity and scale. You would see that the galaxies are not randomly scattered. They are organized, strung along immense, twisting filaments of dark matter and luminous gas, like pearls on an invisible string. These filaments, which can stretch for hundreds of millions of light years, curve and arc through the darkness, connecting at dense, brilliant nodes where thousands of galaxies swarm together in a frenzied gravitational dance. These are the galaxy clusters, the great metropolitan centers of the cosmos. From a distance, this vast network with its filaments, clusters, and the smaller sheet-like walls of galaxies resembles a neural network of cosmic proportions, a celestial brain of unimaginable size. This is the cosmic web. It is the largest single structure we know of, and its existence tells us a profound story about the history and composition of the universe. The web is not made primarily of the galaxies we see. They are merely the visible tracers, the illuminated signs along the highway. The true structure, the skeleton itself, is woven from something we cannot see. dark matter. In the early universe, slight fluctuations in the density of this dark matter acted as gravitational seeds. Over billions of years, ordinary matter, the hydrogen and helium gas that would eventually form stars and galaxies, was pulled by gravity into these pre-existing dark matter wells and filaments. The light follows the dark. The glittering web of galaxies is therefore a perfect trace of the invisible, underlying dark matter scaffold, and this is where the concept of true cosmic emptiness finds its context. For this web is not a solid object. It is a sparse lattice. The filaments, for all their immense length, are incredibly thin. The clusters, for all their brilliance, are isolated islands. But it is the spaces between the threads of this web that hold the real mystery. The cosmic web is not a flat painting. It is a three-dimensional structure, and in the gaps between the filaments and clusters lie vast, spherical regions of profound darkness, the cosmic voids. These are not mere holes or absences. They are an integral part of the web's architecture. The filaments and the voids define each other. You cannot have the web without the empty spaces. The voids are the negative space that gives the positive structure its form and meaning. To truly grasp this, picture a simple sponge. The solid material of the sponge represents the filaments and clusters of the cosmic web, the places where matter has congregated. The holes and pockets within the sponge represent the voids. Now imagine that this sponge is expanding, and that over time the solid material is being pulled ever more tightly into its interconnected strands, while the holes grow larger and merge into even greater cavities. This is precisely what is happening in our universe. The voids are not static. They are dynamic and evolving. As gravity relentlessly pulls matter from the less dense regions into the filaments and clusters, the voids expand, becoming ever emptier, ever darker. This makes the cosmic web not just a structure, but a process. It is a continuous cycle of cosmic urbanization, where matter flows from the rural emptiness of the voids into the dense, bright cities of the clusters, leaving the hinterlands more desolate than before. The voids are, therefore, active participants in the shaping of the universe. Their growth dictates the rate at which the web evolves. Their immense, low-gravity volumes influence how galaxies within the filaments spin and interact. So, when we speak of the Boötes Void or any of its kind, we are not talking about a simple, blank spot on the map. We are talking about a fundamental component of the universe's architecture. A void is a room in the cosmic mansion, a bubble in the cosmic foam, a desert between the shimmering rivers of the web. It is defined by the glittering structure that surrounds it, and in its profound emptiness, it helps to hold the entire visible universe together. The skeleton is not just the bones. It is also the marrow-filled spaces within them. And in the cosmos, those spaces are the great growing voids.
We have laid the groundwork, understanding the grand architecture of the cosmic web. We have seen its brilliant filaments and dense clusters, the great cities and highways of the cosmos. But now, it is time to turn our attention away from the light, away from the crowds, and toward the true majority. It is time to step into the silence and meet the voids. If the cosmic web is the universe's skeleton, then the voids are the marrow-filled cavities within the bones. They are not accidents or afterthoughts. They are not simply the leftover space. They are, in fact, the dominant feature of the entire universe. By volume, over 80% of the cosmic real estate is void, the glittering web of galaxies. That is the minority. We live in a cosmos where emptiness is the rule, and structure is the spectacular exception. So, what exactly is a cosmic void? The name can be misleading, suggesting a perfect, absolute nothingness. But in the language of cosmology, a void is a vast region of space, typically tens to hundreds of millions of light-years across, that is significantly underdense compared to the cosmic average. Think of it not as a completely empty room, but as a sprawling, nearly deserted countryside, where the nearest town is a distant, faint glow on the horizon. The few galaxies that do exist within a void are not the brilliant, spiral giants like our own Milky Way. They are often small, isolated, and irregular lonely outposts in an immense dark frontier. They are the field galaxies. Existing apart from the dense communities of clusters and filaments, The existence of these voids is a direct and dramatic consequence of the early universe. The story begins with the faintest of whispers, tiny quantum fluctuations in the primordial soup of energy that existed a fraction of a second after the Big Bang. These fluctuations were imprints of slightly denser and slightly less dense regions. As the universe expanded and cooled over billions of years, gravity acted as a powerful amplifier. The slightly denser patches pulled in more and more matter, growing into the filaments and clusters of the cosmic web. Conversely, the slightly less dense patches were left behind. Matter was gravitationally siphoned out of them, flowing toward the growing structures. These underdense regions expanded, merged, and evolved into the great voids we observe today. This process makes a void not a static place, but a dynamic and evolving entity. A void is not simply sitting there. It is growing. As the pull of the surrounding web continues to draw matter away, the void becomes ever emptier, and its volume increases. It is a self-reinforcing process. As a void expands, its internal gravitational pull becomes even weaker, making it harder for it to hold on to the little matter it has, leading to further evacuation. They are the ever-widening deserts of the cosmos. The scale of these regions is what truly defies human intuition. The local void, the one in which our own Milky Way galaxy resides on its fringes, is estimated to be over 100 million light-years across. To cross it at the speed of light would take 100 million years. Within such a volume, you could place thousands of galaxies like our own. And yet, it is characterized by their profound absence. The galaxies that do border it, including our local group, are slowly moving away, falling toward the denser attractors of the Virgo cluster and the great further emptying the void. This perspective turns our place in the universe on its head. We often think of our galaxy as being in a neighborhood, and we are, but that neighborhood is defined as much by what isn't there as by what is. We are not in a bright, central city. We are in a suburban filament on the shoreline of a vast, dark ocean of nothingness. The voids are our cosmic context. To meet the voids, then, is to finally see the universe for what it truly is, not a solid, glittering firmament, but a sparse, web-like structure floating in an overwhelming sea of near nothing. They are the great, empty rooms in the house of the cosmos. Rooms so vast that their walls are made of galaxies, and their ceilings are a blackness so deep it reveals the fundamental emptiness of space itself. And the greatest of these rooms, the most startlingly empty of them all, is a place that astronomers discovered almost by accident. A void so large it challenged our very understanding of what was possible. A place called the Boötes Void. But that is a story for another time.
The story of how humanity discovered the great voids is not a tale of someone pointing a telescope at a dark patch of sky and proclaiming it empty. It is a far more subtle and revolutionary story, one that is inextricably linked to our struggle to map the cosmos in 3 dimensions. The discovery of nothing, it turns out, required first mapping everything around it. For centuries, astronomy was a 2-dimensional pursuit. We could chart the positions of stars and the smudgy patches of nebulae on the celestial sphere, but we had no real concept of their depth. A galaxy could be a nearby cloud or a distant island universe. We simply did not know. The key that unlocked the 3rd dimension was a tool we've already met: redshift. By measuring how much the light from a galaxy was stretched towards longer, redder wavelengths by the expansion of the universe, astronomers could calculate its distance. For the first time, we could plot galaxies not just by where they appear in our sky, but by how far away they truly are. The pioneering work began in the late 1970s and early 1980s. Astronomers like Robert Kirshner, Augustus Oemler, Paul Schechter, and Stephen Scheckman embarked on Herculean surveys. Night after night, they would painstakingly collect the spectra of hundreds, then thousands, of faint galaxies. It was a slow, meticulous process, like surveying a vast, dark forest by measuring the location and height of every single tree. When they began to plot their data, the first inklings of a grand structure emerged. They weren't seeing a random scatter. They found a striking chain of galaxies in the constellation Coma Berenices, a filament that seemed to point toward a known, dense cluster of galaxies, the Coma cluster. But as they mapped the region around it, they noticed something peculiar. Directly in front of this chain, in the direction of the constellation Boötes, there was a startling gap, a region where their telescope, aimed at a patch of sky covering millions of light-years, found almost nothing. The galaxies simply vanished. It was as if their map of the forest had revealed a circular clearing of unimaginable size. In 1981, Kirshner and his team published a landmark paper titled "A Million Cubic Megaparsec Void in Boötes." The title itself betrayed a sense of awe and disbelief. They had found a spherical region roughly 250 million light-years across that contained a mere handful of galaxies, where their models predicted there should be thousands. The initial reaction from the scientific community was profound skepticism. Could this be a mistake? An artifact of their observation technique? Perhaps there was intervening dust in our own galaxy blocking the view? But the data held firm. The void was real. This was the moment the cosmic voids shifted from theoretical possibility to observed reality. The discovery of the Boötes Void was a seismic event in cosmology. It was the first time the empty rooms of the cosmic web had been definitively identified. It proved that the universe's large-scale structure was not just defined by where matter was, but equally by where it was not. The Boötes Void was not just an absence. It was a positive feature, a colossal bubble in the foam of the cosmos. This breakthrough triggered a gold rush in cosmic cartography. Other teams began reanalyzing their data and starting new, more ambitious surveys. They soon found that the Boötes Void was not a unique monster. It was an extreme example of a common phenomenon. The universe was filled with voids of all sizes. They found the local void, nudging up against our own local group of galaxies. They found the Taurus Void, the Microscopium Void, and countless others. With each new survey, like the Sloan Digital Sky Survey, which automatically mapped the positions of millions of galaxies, the picture of the cosmic web grew sharper and more detailed. The spongy, filamentary structure, punctuated by vast, dark bubbles, became the standard model of our universe. The discovery of nothing, therefore, was one of the most significant findings in modern astronomy. It didn't just add a new object to the celestial menagerie. It fundamentally rewired our understanding of cosmic geography. It showed us that the universe is primarily a place of vast, empty volumes, and that the galaxies we cherish are mere trace elements, clinging to the intersections of an invisible scaffold. The story of this discovery is a testament to human curiosity, to the fact that by diligently mapping the light, we can ultimately infer the profound and shaping power of the dark.
In the annals of cosmic geography, there are curious oddities, and then there are the landmarks that redefine the map itself. The Boötes Void is such a landmark. It is not merely a void, it is the void against which all others are measured. The superlative, the champion of emptiness. Its discovery was not just the finding of an interesting feature, but a moment that stretched the very limits of what astronomers thought was structurally possible in our universe. The year was 1981. Robert Kirshner and his team were not on a dedicated quest to find nothing. They were engaged in the noble, grinding work of cosmic cartography, using redshift measurements to map the three-dimensional distribution of galaxies in a vast swath of the northern sky. Centered on the constellation of Boötes, the herdsmen, they were patiently building a picture of the universe's structure, point by point, galaxy by galaxy. But as their map began to take shape, a troubling anomaly emerged. Right in the middle of their survey area was a gaping hole, a spherical region of space, an estimated 250 million light-years in diameter, was almost completely barren. The initial reaction was not excitement, but profound skepticism. The finding was so extreme that the first assumption was error. Had their telescope malfunctioned? Was there a thick cloud of dust within our own Milky Way, blocking their view of the galaxies beyond? They checked and rechecked their instruments, their methodology, and the local interstellar environment. Every check came back clear. The emptiness was real. It was not an instrumental artifact. It was a feature of the cosmos. In their seminal paper, the tone was one of cautious astonishment. The title itself, a question. 1,000,000 cubic megaparsec void in Boötes. They had stumbled into a cavern so vast it seemed to defy the prevailing understanding of cosmic structure. To understand why the Boötes Void was so shocking, we must consider its scale. A sphere 250 million light-years across is a volume of space, so mind-numbing that all human language fails to capture it. Within this volume, you could fit over 10,000 galaxies, like our Milky Way, with room to spare. You could place our entire local group of galaxies, and thousands of its neighbors, and they would be lost in the immense. According to the average density of the universe, this region should be home to several thousand bright galaxies. Early surveys, however, found only a paltry handful. Later, more sensitive observations would raise the count to around 60. But this is still a profound and shocking desolation. It is a cosmic metropolis zoned for millions of inhabitants, where only a few dozen lonely farmsteads, an otherwise endless dark plain. The Boötes Void earned its title, the Great Nothing, It became the definitive example of a super. Its existence presented an immediate and serious challenge to cosmological models. The nascent theory of the cosmic web, driven by dark matter, could produce voids. But could it produce a void this large and this empty? The Boötes Void pushed the boundaries of the possible, forcing theorists to refine their simulations of the early universe. It tested the limits of the Gaussian fluctuations from the Big Bang, suggesting that perhaps the primordial universe had allowed for rarer, more extreme underdensities to form than anyone had anticipated. But the void is more than just a statistical outlier. It is a physical place, and its few inhabitants are objects of intense fascination. The galaxies within the Boötes Void are not like the vibrant spirals and ellipticals of the crowded web. They are often small, irregular, and anemic galaxies that have been starved of the intergalactic gas that fuels new star formation. They are the isolated survivors, evolving in a quiet, dark, and resource-poor environment, cut off from the cosmic mainstream. Studying them is like studying the flora and fauna of a deep-sea trench. They are uniquely adapted to an extreme habitat. The discovery of the Boötes Void was a pivotal moment in astronomy. It was the moment we moved from suspecting the universe was structured to understanding that its structure was dominated by emptiness on a scale we had never dreamed of. It transformed voids from theoretical curiosities into central characters in the cosmic story. The King of Nothing was not an absence to be ignored, but a colossal presence that demanded an explanation. It stood as a monumental challenge, a silent testament to the fact that the universe, in its quest to build great structures, also creates even greater absences. And in the profound quiet of that absence, we are forced to reconsider everything we thought we knew about the cosmos we call home.
We have a name for it now, the Boötes Void. We know it is a colossal sphere of near nothingness, but to truly grasp what that means, to feel its scale in your bones, we must move beyond the dry numbers. A diameter of 250 million light-years is a figure so vast it becomes a meaningless abstraction. Our brains, evolved to navigate a world of trees and rivers, simply cannot process it. So let us try a different approach. Let us use a series of thought experiments, of shrinking analogies, to slowly coax our minds into comprehending the terrifying immensity of this great nothing. First, let us bring the void home. Imagine our own galaxy, the Milky Way, a majestic spiral of a few 100 billion stars, so vast that light itself takes 100,000 years to travel from one end to the other. Now picture placing this entire galaxy at the very center of the Boötes Void. From that central point, you would have to travel in any direction for over 125 million years at the speed of light, before you would even reach the void's hypothetical wall. Our entire galaxy, with all its stars, worlds and mysteries, would be a single, lonely speck of dust adrift in the center of an empty sphere, so large it defies all sense of proportion. The Milky Way would be utterly hopelessly alone, but perhaps even that is too large. Let us shrink our perspective further. Let us imagine a scale model where our entire solar system, from the Sun to the distant icy realm of Pluto's orbit, is shrunk down to the size of a single standard coffee mug. This mug represents everything we traditionally call home. On this scale, the next star system, Proxima Centauri, would be another coffee mug located about 4,000 miles away, roughly the distance from New York to Berlin. This already feels desolate, but this is the crowded galactic disk. Now let's place our solar system mug inside our model of the Boötes Void. If the void is a sphere 250 million light-years across, and our coffee mug is the solar system, then the scale of the void becomes an empty sphere approximately 3 million miles in diameter. That is a vacuum so vast you could fit over 12 Earths, lined up side by side within its empty expanse. And our entire cosmic neighborhood, our sun and all its planets, is just one lonely coffee mug floating in the very center of this immense, silent sphere. The nearest other coffee mug, the next significant concentration of matter, would be somewhere on the distant, invisible surface of this million-mile-wide bubble. Let us try one more analogy, this time using speed as our measure. Imagine we possessed a starship, a marvel of engineering capable of traveling at the speed of light, a velocity so supreme that it can circle the Earth 7 times in a single second. You point the nose of your ship toward the heart of the Boötes Void and engage the engines. For the first 100,000 years, you are simply traversing the diameter of our own Milky Way. You then emerge into the intergalactic darkness. The years turn into millennia, the millennia into millions of years, You are traveling at the ultimate speed limit of the cosmos, and yet the emptiness around you is unchanging. After 125 million years of continuous light-speed travel, you would only just be reaching the far side of the void. To put that timescale into perspective, 125 million years ago on Earth, the first primitive placental mammals were just beginning to evolve. Your entire journey across this single void would span the time from the rise of the dinosaurs to the present day. This is the scale of the Boötes Void. It is not merely a gap. It is a chasm that swallows time and space. It is a volume where the fundamental concept of neighborhood breaks down completely. The sheer size of it is what makes its emptiness so statistically shocking and so philosophically unnerving. The universe, for all its laws and structure, has somehow permitted a region of such monumental absence that it feels less like a feature and more like a cosmic oversight. This scale is the source of its mystery. How could gravity, which pulls matter together, have left a region this large so utterly vacant? The existence of the Boötes Void is not just a curiosity. It is a fundamental challenge. It forces us to ask if our understanding of the initial conditions of the Big Bang is complete, or if there are rarer, more extreme fluctuations in the cosmic recipe than we ever thought possible. So, when you hear the number 250 million light-years, do not just nod and move on. Stop. Try to feel the weight of that distance. Try to imagine the silence that would fill a space so large. The Boötes Void is not just big. It is a lesson in cosmic humility, a demonstration that the universe operates on a canvas so expansive that even its nothingness is of a scale we can barely, just barely, begin to conceive.
We have measured the Boötes Void. We have strained our minds with analogies to grasp its scale. But to truly feel its existential weight, we must perform one final profound act of imagination. We must close our eyes and picture not the void from the outside, as a feature on a map, but from within. Let us embark on a thought experiment. Let us teleport our entire Milky Way galaxy and our position within it to the very heart of the Boötes Void. What would we see when we looked up? First, the familiar would vanish. The Milky Way, that glorious hazy river of light that has arched over every human being throughout history, would be gone. Not faded, not dimmed, but absent. We did not bring it with us. We are within it, and from this central, isolated position, its brilliant disk would be the ground beneath our feet, not a spectacle above our heads. We would be standing on a world at the center of a ghostly, flat wheel of stars, looking out into the universe, and we would see almost nothing. This is the core of the experience. We are not talking about a dark night sky as we know it, where 1,000 pinpricks of light still gleam. We are talking about a blackness so profound, so absolute, that it would feel less like a sky and more like a physical presence, a shroud of nothingness pressing in from all sides. Your eye, desperate for a point of light to latch onto, would find almost none. The constellations, those familiar patterns that have guided navigators and storytellers for millennia, would be utterly erased. Orion, Ursa Major, the Southern Cross, all of them gone. They are stars in our own galactic neighborhood, and from the void center they would still be visible, but they would be lost, insignificant specks against the overwhelming void beyond. Let's be specific. In our actual night sky, with the naked eye on a clear, dark night, you can see a few thousand stars, all residents of the Milky Way, and a handful of external galaxies, the Andromeda Galaxy and the Magellanic Clouds being the most prominent. From the heart of the Boötes Void, the view of our own galaxy would be similar, though perhaps even richer without the obscuring dust lanes from our current off-center position. But when you looked beyond our galactic plane, into the true depths of intergalactic space, the view would be revolutionary in its emptiness. The Andromeda Galaxy, our closest major galactic neighbor, currently a faint, smudgy oval visible to the naked eye, would be millions of light-years away, far beyond the void's empty wall. It would be invisible. The Triangulum Galaxy, the Pinwheel Galaxy, all the bright local galaxies we can see from our true location would be absent. The entire Virgo cluster, a sprawling metropolis of thousands of galaxies, would be a distant, unreachable continent, its light far too faint for our eyes to perceive. What would remain? A handful of the void's own lonely inhabitants. Perhaps a dozen or so faint ghostly smudges might be visible with a powerful amateur telescope, where from our current location we can see thousands. These would be the isolated, anemic galaxies that call the void home. They would not be the brilliant spirals and ellipticals we are used to. They would be small, faint, and irregular, the cosmic equivalent of a few lonely, flickering candles in a cavern the size of a continent. Their light would be old and weary, having traveled for tens of millions of years across the void just to reach us. The dominant feature of the sky would not be light, but the lack of it. The blackness would be so pure, so uninterrupted, that it might feel solid. You could almost believe that the universe ended just beyond the rim of the Milky Way. This is the true nature of a void. It is not just a low-density region on an astronomer's chart. It is a sensory experience of profound isolation. The cosmic web, the great connective tissue of the universe, would be entirely invisible. We would be adrift in a bubble of negation, cut off from the rest of creation. This visualization is more than just a flight of fancy. It is a crucial tool for understanding our place in the cosmos. It reminds us that our vibrant, star-strewn sky is a local phenomenon, a product of our fortunate location in a relatively dense part of the cosmic web. We live in a bright suburb, not an isolated farmstead in the great dark. The Boötes Void shows us what the universe is mostly like: dark, empty, and silent. Our experience of a crowded sky is the illusion. The void is the reality. To look up from its center would be to gaze into the true, naked face of the cosmos, a face of breathtaking and terrifying emptiness.
We have ventured into the heart of the Boötes Void in our minds, and we have found a sky of almost perfect blackness. We have called it the Great Nothing. But this is where our story takes a crucial, fascinating turn. The name is a dramatic and useful shorthand, but it is not scientifically precise. To call the Boötes Void nothing is to misunderstand its nature in a fundamental way. The void is not a perfect vacuum. It is a realm of profound extremes, where the little that exists tells a story just as compelling as the overwhelming emptiness that defines it. First and most famously, there are the galaxies. While the void contains only a few dozen galaxies where thousands should exist, those few dozen are not merely statistical errors. They are real, physical islands in the dark. They are the reluctant inhabitants of the emptiness, and their very existence is a subject of intense study. How did they get there? Were they simply left behind, like lone trees in a clear-cut forest, as the rest of the matter was gravitationally siphoned away into the surrounding cosmic web? Or did they form an S2 from the meager scraps of gas that remained in the void's interior? Their isolation has profound consequences for their evolution. These are not the grand, elegant spirals like our Milky Way or the massive spherical ellipticals found in dense clusters. Spiral galaxies require a stable, rich environment and a steady inflow of gas to maintain their majestic arms. The void offers no such luxury. The galaxies within it are often small, irregular, and anemic. They are starved of the intergalactic hydrogen gas that is the lifeblood of star formation. Without a constant supply of fresh fuel, and without the gravitational nudges from galactic neighbors that can trigger stellar nurseries, their star-forming factories have largely shut down. They are, in a cosmic sense, quiet, aging, and lonely. Studying them is like studying a unique ecosystem in a deep desert of place, where life, or in this case, stellar life, clings to existence under the most austere conditions. But the galaxies are the obvious part. The true, deeper mystery of the void lies in what fills the space between them. This is the intergalactic medium within the void, and it is here that we find the most subtle and pervasive evidence that the void is not truly empty. Imagine the purest vacuum chamber ever created on Earth. Now, imagine a volume 1,000,000 times more rare. You are now approaching the density of the intergalactic medium inside a void like Boötes. This is not a complete absence of matter. It is a diffuse, ultra-tenuous soup of primordial hydrogen and helium gas, the leftover ingredients from the Big Bang that never coalesced into galaxies. Its density is so low that a volume of space the size of a modern sports stadium might contain only a single, lonely atom. Yet, this gas is not uniformly distributed. It forms a delicate, wispy web of its own filaments of gas, so faint they are virtually undetectable. Stretching between the few galactic islands, this is the skeleton of the void, the faintest echo of the cosmic web on a miniature and far emptier scale. Furthermore, this empty space is not devoid of energy. It is permeated by the cosmic microwave background radiation, the faint afterglow of the Big Bang. It is pierced by neutrinos, those ghostly particles that flow through everything, utterly unaffected by the void's emptiness. And, most intriguingly, it is dominated by the mysterious presence of dark energy. In fact, the void is a perfect laboratory for studying dark energy. In the dense regions of the cosmic web, the powerful gravitational pull of galaxies and dark matter fights against the outward push of dark energy. But in the void, where gravity is weak to the point of negligibility, dark energy reigns supreme. The expansion of the universe proceeds fastest here, in the emptiest places, as the void itself is being stretched apart from within by this mysterious force. So, the Boötes Void is not a sterile, static hole, it is a dynamic environment. It is a place where a handful of lonely galaxies age in quiet isolation. It is filled with a gas, so thin it defies our concepts of substance. And it is a cosmic arena where dark energy performs its most visible work, accelerating the expansion of nothingness itself. The great nothing is, in reality, a great almost nothing, and in that crucial distinction in the subtle study of its few galaxies and its tenuous gas, we learn profound lessons about the forces that shape all of reality, from the brightest clusters to the darkest, quietest voids in between.
Within the immense, light-starved expanse of the Boötes Void, the handful of galaxies that do exist are more than just celestial curiosities. They are profound mysteries. They are the lone survivors on a forgotten frontier, and their very presence raises a question that cuts to the heart of cosmic evolution. How did they get there? The answer is not simple, and it forces us to choose between two equally compelling and haunting narratives. Are these galaxies the stranded remnants of a once populated region, or are they the solitary natives born from almost nothing in the great dark? The first story we can tell is a tragedy of cosmic proportions, the tale of the left behind. In this scenario, the Boötes Void was not always the desolate place it is today. Billions of years ago, it may have been a fairly average region of the universe, with a population of galaxies similar to any other. But it possessed a fatal flaw. It was slightly less dense than its surroundings. As the cosmos evolved, gravity acted like a ruthless cosmic real estate agent. The denser filaments and clusters surrounding the void exerted a powerful pull, slowly but irresistibly siphoning matter away. Galaxies on the fringes of the void would have been the first to be lured away, drawn towards the bright lights of the emerging cosmic cities. Over billions of years, this gravitational evacuation would have accelerated. The void expanded, growing emptier as its material was drained into the web. The galaxies we see today, then, could be the final, stranded holdouts. They are the ones that by chance, or due to some initial slower velocity, failed to escape the void's growing gravitational poverty. They are the last inhabitants of a ghost town, watching as all their neighbors slowly packed up and left for the denser structures beyond the horizon. In this narrative, these galaxies are relics, frozen in time, their evolution stunted by their catastrophic isolation. The second story is even more radical. It is the story of the true natives. In this version, these galaxies never had many neighbors to begin with. They formed in situ right where they are, from the meager scraps of dark matter and primordial gas that were left swirling in this vast, underdense region after the initial rush of cosmic structure formation. This is a far more difficult feat. Galaxy formation is a process that thrives on density. Gas needs to cool, collapse, and fragment, a process greatly helped by the gravitational nudges and collisions that are commonplace in the crowded galactic clusters. For a galaxy to form in the void, it would have to do so against all odds, like a single, sturdy tree managing to grow in the middle of a vast, arid salt flat. It would have had to gather up the incredibly diffuse hydrogen gas that permeates the void, a process that would be slow, inefficient, and likely produce a very different kind of galaxy. This theory suggests that these isolated galaxies are not the impoverished cousins of our Milky Way, but a unique class of object that evolved on a separate path entirely, shaped not by community, but by a profound and enduring solitude. The evidence? We have points to a reality that likely incorporates both stories. The galaxies within the Boötes Void are indeed strange. They are often blue compact dwarfs or small, irregular galaxies. They are not the grand, well-ordered spirals we see in denser environments. Their star formation is often sporadic and anemic. They lack the constant influx of fresh gas that fuels stellar nurseries in more sociable parts of the universe. Some show signs of having experienced a burst of star formation long ago, which then sputtered out as their fuel reserves were depleted, a history consistent with being stranded and cut off from the cosmic supply chain. Others appear to be slowly consuming the last vestiges of gas from their immediate surroundings, a quiet and final act of cosmic subsistence farming. Their loneliness also makes them incredibly valuable to astronomers. A galaxy in a dense cluster is like a person in a bustling city. Its behavior is shaped by constant interactions with its neighbors. It can be difficult to discern its intrinsic properties, but a galaxy in the void is like a lone hermit in the wilderness. Its properties, its shape, its rate of star formation, its structure are almost entirely a result of its own internal dynamics and its isolated environment. By studying these hermits, we can understand the fundamental baseline process of how a galaxy evolves when left entirely to its own devices. The mystery of the lonely galaxies, therefore, is not just about their origin. It is about what they can teach us about the resilience of structure in a universe that seems to prefer emptiness. They are the extreme test cases for our theories of galaxy formation. Whether they are the stranded remnants of a busier past or the true natives of the void, their continued existence is a testament to the fact that even in the greatest of nothings, the universe still finds a way to spark a little light. They are the ultimate symbols of cosmic isolation, and in their quiet, aging glow, they hold the secrets to understanding one of the most extreme environments the cosmos has to offer. If the Boötes Void is a continent-sized desert, then the galaxies within it are not the thriving cities of the fertile coast, nor are they the bustling towns of the inland river valleys. They are the isolated outposts, the remote trading posts, or perhaps even the solitary hermit's caves scattered across a vast and barren expanse. These are the reluctant inhabitants of the void, and their existence is a lesson in how environment dictates destiny. They are not merely smaller or fainter versions of our Milky Way. They are a different kind of cosmic citizen altogether, shaped by their profound isolation into something strange and revealing. To understand them, we must first abandon our galactic chauvinism. We tend to view the majestic spiral galaxy as the pinnacle of cosmic structure, a grand, star-forming metropolis like our own. But in the dense, urban centers of the universe, the galaxy clusters, such spirals are often harassed. Stripped of their gas and transformed into featureless elliptical galaxies through violent collisions and close encounters. The void offers a refuge from this chaos, but it is a refuge that demands a heavy price: solitude and scarcity. The galaxies that have adapted to this environment are a peculiar bunch. Many are small, irregular, and seemingly unfinished. They lack the elegant symmetry of a spiral or the smooth, rounded glow of an elliptical. They are cosmic scraps, ragged collections of stars and gas that have never experienced the gravitational discipline of a large-scale structure or the transformative shock of a galactic merger. Their most defining characteristic is their quietness. Star formation is a social activity, often triggered by gravitational interactions or by accreting fresh gas from the intergalactic medium. In the void, both are in desperately short supply. These galaxies are, for the most part, starved. They are cut off from the dense filaments of cold hydrogen gas that flow along the cosmic web and fuel star birth in more connected regions. What little gas they possess is often locked up in a diffuse, warm state, unable to cool and collapse into the dense clouds that birth new stars. As a result, many void galaxies are red and dead long before their time, their stellar populations aging in place with no new bright blue stars to rejuvenate their appearance. They are like quiet, retirement communities for stars, where the frenetic energy of youth has long since passed. Yet paradoxically, some void galaxies tell a different story. Astronomers have found a population of blue compact dwarfs within voids. These are small, intensely blue galaxies experiencing a violent, albeit short-lived burst of star formation.
How can this be in a place so devoid of fuel?
The answer may lie in their utter isolation. Without the gravitational jostling of neighbors, the gas within these galaxies can remain relatively stable for billions of years, slowly pooling and accumulating. Then, a slow, internal trigger, perhaps the gentle collapse of a gas cloud under its own weight, can set off a firestorm of star formation all at once, like a single spectacular flash of lightning in an otherwise dark and silent sky. It is a brief, brilliant bloom in the desert, a final, desperate spending of reserves accumulated over eons of solitude. This isolation makes them invaluable to science. A galaxy in a cluster is like a person whose life story is shaped by a constant crowd of friends, rivals, and collisions. It's hard to know which of its traits are innate and which were imposed by its environment. But a void galaxy is a hermit. Its properties, its shape, its stellar population, its very existence are almost entirely a product of its own internal physics and its initial conditions. By studying these hermits, we can discern the bare essentials of galaxy formation, stripped of all the complex interference of a crowded cosmos. They are the control group in the grand experiment of the universe. The reluctant inhabitants of the void are therefore not failed galaxies. They are pure galaxies. They represent a path of galactic evolution that is quiet, slow, and dictated by internal rhythms rather than external forces. Their lives are a testament to the fact that the cosmos allows for many different kinds of existence. Not all galaxies are destined for the bright lights and violent interactions of the cosmic cities. Some are destined for the quiet, the dark, and the slow, patient aging of the great, empty frontier. In their reluctant isolation, they hold the key to understanding the most fundamental and most solitary of cosmic lives.
The existence of the Boötes Void, and the countless others like it, presents a fundamental question. How does a universe governed by gravity, a force that pulls matter together, end up with such colossal regions of nothingness? The answer is not that gravity failed, but that it succeeded with a brutal and unforgiving efficiency. The story of void formation is a cosmic epic that begins with the faintest whisper of a beginning and unfolds over billions of years, driven by the invisible hand of dark matter. It all starts in the first infinitesimal fraction of a second after the Big Bang. The universe was not perfectly smooth. Thanks to quantum fluctuations, it was imprinted with tiny random variations in density, ripples in the fabric of space-time. Imagine a vast flat lake on a perfectly calm day, but at the microscopic level, the surface is ever so slightly textured. These ripples were the seeds of all future structure, the cosmic DNA that would determine where galaxies would shine and where nothingness would reign. As the universe expanded and cooled, these ripples were frozen into the distribution of matter. But there was a catch. The most dominant form of matter was not the stuff that would become stars and planets. It was dark matter. This mysterious, invisible substance formed a scaffolding throughout the cosmos. And because dark matter doesn't interact with light or with itself through any force except gravity, it was free to begin clumping together immediately, long before ordinary matter could. This is the crucial first act. The dark matter began to collapse under its own gravity into a vast invisible web. The slightly denser patches, the peaks of those primordial ripples, became the anchors, the future nodes of galaxy clusters. The regions around them began to drain matter inward. Conversely, the slightly less dense patches, the troughs of the ripples, were the embryonic voids. They had less gravitational pull, so they were less able to hold onto their matter. Now enter gravity's relentless work. Over billions of years, gravity acted as a cosmic real estate agent, orchestrating a great migration of matter. The denser regions, with their stronger gravitational pull, began to siphon matter away from the less dense regions. It was a case of the cosmic rich getting richer and the poor getting poorer. The underdense regions saw their meager matter slowly, but surely stolen away, flowing along the emerging dark matter filaments toward the growing clusters. This process created a powerful feedback loop. As a region lost matter, it became even less dense. With less matter, its gravitational pull weakened further, making it even easier for the surrounding dense regions to pull away what little remained. The underdense region began to expand, not because it was pushing outward, but because it was being emptied from the edges inward. It was a gravitational evacuation, a cosmic white flag signaling surrender to the surrounding structures. What we call a void, then, is not a static bubble that was born empty. It is a dynamic, growing entity. It is a region that is actively being carved out and defined by the gravitational dominance of the cosmic web that surrounds it. The void is the negative space that is left behind as the positive structures of the universe, the filaments and clusters, draw in everything they can. The Boötes Void is not an anomaly. It is the ultimate expression of this process. It is a region where an initial, slightly larger underdensity was targeted for an exceptionally thorough evacuation. This narrative, supported by sophisticated computer simulations of the universe's evolution, provides a stunningly accurate picture. When scientists program the laws of physics and the initial conditions of the Big Bang into these simulations, they watch as the cosmic web emerges naturally. The simulations don't just produce the glittering filaments of galaxies. They inevitably and necessarily produce the vast dark voids in between. The voids are not a bug in the cosmic code. They are a fundamental feature of the program. Therefore, the emptiness of the Boötes Void is not a mystery in the sense of being unexplained. It is a direct consequence of the universe's initial conditions and the relentless billion-year-long operation of gravity upon the invisible scaffold of dark matter. The void is a fossil. It is the preserved and magnified imprint of a tiny quantum underdensity from the dawn of time. When we look into its profound darkness, we are not looking at a failure of creation, but at a perfect and predictable outcome. We are looking back at the faintest of ripples, grown to an impossible scale by the patient, unyielding hand of gravity.
To understand the great voids, we have so far spoken of gravity as the primary architect, but this is an incomplete picture, like describing the shape of a cathedral by only looking at the stained glass and not the stone arches that hold it up. The true master builder, the force that dictated where the cosmic web would form and, by extension, where the great voids would be carved, is dark matter. It is the invisible skeleton of the universe, and its ghostly presence is the very reason the Boötes Void can exist. Let us return to the beginning. In the fiery aftermath of the Big Bang, the universe was a searing, dense plasma of particles and light. Ordinary matter, the protons, neutrons, and electrons that would become everything we see, was trapped. It was constantly buffeted by the intense pressure of radiation, preventing it from clumping together effectively. If ordinary matter were the only player, its gravity would have been far too weak to overcome this pressure, and the universe would have remained a formless, expanding fog, never coalescing into the structures we see today. There would be no galaxies, no clusters, and no vast voids between them. But dark matter was different. This mysterious substance, which makes up about 85% of all matter in the universe, is dark because it does not interact with light or electromagnetic forces. It feels gravity, and it may feel the weak nuclear force, but it is utterly oblivious to the hurricane of radiation that was scattering ordinary matter. This immunity was its superpower, while ordinary matter was being pushed and smeared around. Dark matter was free to simply sit there and feel the pull of gravity. It could begin collapsing into structures immediately. The faint density ripples from the Big Bang were therefore first imprinted not on the visible universe, But on this dark matter sea, the slightly denser patches of dark matter acted as gravitational seeds. Over hundreds of millions of years, they pulled in more dark matter from their surroundings, growing into an immense cosmic scale scaffold, a network of dense knots connected by filaments surrounding vast empty bubbles. This was the birth of the cosmic web, woven in darkness long before the first star ever shone. Only then could ordinary matter join the party. As the universe expanded and cooled, the pressure of radiation faded. The atoms of hydrogen and helium, once tossed about, were now free to be gravitationally drawn into the deep wells already carved out by the dark matter. The light followed the dark. The glittering galaxies we see today did not form randomly and then arrange themselves into a web. They formed inside the pre-existing dark matter infrastructure. They are the illuminated signs hung upon an invisible framework. This narrative completely reframes our understanding of voids. A void, like the one in Boötes, is not a region where dark matter is absent. On the contrary, it is a region dominated by a vast, underdense halo of dark matter. The gravitational pull of the surrounding web, itself made of dense, dark matter, has siphoned the dark matter from the void's center, just as it siphoned the ordinary matter, leaving behind a deep, underdense region. The void is a feature of the dark matter distribution. First and foremost, its emptiness is a direct reflection of the underlying dark matter skeleton. This explains why the voids are so spherical and why the galaxies within them are so isolated. The dark matter halo of a void exerts a weak but pervasive gravitational pull that is fairly uniform in all directions. This tends to sculpt the void into a rounded shape. The few galaxies that remain inside are trapped there, not by the gravity of other galaxies, but by the gentle, basin-like gravitational field of the void's own dark matter halo. They are like boats caught in a vast, calm, and nearly empty bay, unable to sail over the gentle, invisible underwater ridge that separates them from the cosmic ocean beyond. Therefore, dark matter is not just a component of the universe. It is its fundamental architect. It dictated the blueprint. It decided where the great metropolitan clusters would rise and where the deserted countryside would be. The Boötes Void is a monument to dark matter's shaping power. It is a colossal shadow cast not by an absence of light, but by the specific, structured absence of an invisible substance. When we gaze into the void, we are not looking at a failure of structure. We are looking at the negative space in a sculpture shaped by the unseen hand of dark matter. The great emptiness, in its own silent way, is one of the loudest confirmations we have that the universe is built upon a hidden, dark foundation.